objective, Beto, please? Everyone on three, 1, 2, 3. Right. So in your FAIR model, instead of writing linear relationships, or you can write linear relationships, and underneath that, write best fit lines. So whenever you hear best fit lines, linear relationships, we're talking about the same thing. All right. So in your FAIR model, what are best fit lines? I'm going to forward your screen. I'm going to leave the objective up here in case some of you are not finished copying. But according to the definition, it says linear relationships or best fit lines are a straight line that best fits and provides a good description of a set of data. Best fit lines are a straight line that best fits and provides a good description of a set of data. A best fit line is a straight line that best fits and provides a good description of a set of data. Copy that. Okay. I'm going to go over an example with you according to the definition. Here it goes. It says, once again, linear relationships or best fit lines are a straight line that best fits and provides a good description of a set of data. Right now I'm going to show you some data in regards to the retail price of a book and the actual price of a book. So they're going to compare those two things by using some data, and they're going to plot it for you. So look up to the screen, please. It's not going to appear on your iPad. It's going to appear over here. Everybody see it? Yeah. Let me zoom in. So those of you that can't see it from back there, there's my data. So according to the definition, a best fit line is a straight line. Do I have a straight line going through the data? Yes. And what else do we notice about it? That it's the definition says that it best fits and it provides a good description of the data. So first of all, look at all these points. If we're reading it from left to right, it's going either up to the top right or it's going down to the bottom right. Is that correct? Yeah. In which direction is this one going? Up to the top right. Do you guys notice that? That's why they sketched a straight line going in that direction. Now, what other thing do we notice? Look up, please. Look at these and look at these. Talk it over with your neighbor. What else do you notice from the best fit line and that data? Talk it over, please. Let's see. Ethan, what do you notice? The line doesn't start at the origin. That's a good observation. What else do you notice, Caleb? There's the same number of points above the line and below the line. So it's pretty well balanced. Does that make sense? Yeah. That's why it's called a best fit. It fits the entire data going that direction. Copy that, please, on the example box. Okay. You nice. Copy that, please. Okay. So according to the definition, once again, we said that it's a straight line. Do we have a straight line? Yes. And it provides the best fit and a good description of the set of data. All right. Everybody there so far? Yeah. Okay, let me show you a non-example. Let's see if you can actually tell the difference from one to the other. Here it goes. Look up. Tell your neighbor why that's not a best fit line. Copy that, please.
Yeah, it's red, not green. I got it. It's green.
Copy that, please. Copy that.
Doesn't it have a little box that says data exceeded line?
All right, here we go.
That's a not good feature.
Oh, what was the question? I'm sorry.
Oh wow, how do you prepare for things?
Yeah, but I changed them. From me to your, just to, you know.
That way no one can copy their siblings. Their kids like
No. This year. Yeah, so you guys are not guinea pigs. You guys are the special group. All right, here we go. So, according to what we just learned in regards to best fit lines, share with your neighbor a couple of hashtags that you would share with someone that would clarify what best fit lines are. Okay, hands for volunteer. Francesca. Hashtag best fit line. Okay. Another hashtag. Vivier. Hashtag not connect the dots.
Really?
Be nice.
No, like.
Matthew. Hashtag straight. Be nice. Line. What else?
Hashtag green line.
Hashtag green line. Wow. What's that? I can't hear you. Yeah, we'll have one pretty soon. All right. We good with that? All right. So today, guys, if you notice throughout the year, we've been practicing, and I've been leaving some home play in regards to the practice smarter balance test for you to take home. You guys remember that?
No.
Yes. Now, some of the presentations, the way they present some of the problems, it's a little bit different from the way we present it in class or you see it presented in the books. Now, the only difference is that they chunk it out and they ask particular questions similar to, if you guys remember that systems problem with Ms. Quintanilla making the headbands for the softball team. Yeah. Remember how I actually broke it down with questions that were chunked out towards the end? That's kind of like the way they're going to present it. But the way I want to present it today to you is that so you guys can see some of the thinking that goes through in regards to showing some of the graphs, presenting some of the data. So we're going to look at one example really quick. So look at your screen. I'm going to forward that. I'm going to leave this one up here for right now. So look at that problem. And can you read it out loud, please? Matthew.
In this task, you will use data to create a model that shows the relationship between animal body weight and pulse rate measures. Then you will examine additional data to evaluate the model.
Olivier, continue.
A study states that the relationship between an animal's pulse rate and body weight is approximately linear. The study data are below.
Okay. And if you notice, look at the data that they gave us. They gave us the first column of the different animals that they used. And then they start giving us numbers. Now, this is very similar, and you guys can look at it. It's very similar to the input-output tables I gave you guys throughout the year, right? What variable does the first column of data correspond to? X is correct. Therefore, that means that first column of numbers, that's our domain. Is that correct? Now, look at the last column. The last column will be our Y value, also known as the range. Now, most of the time, they're going to give us a graph that goes along with the data. But before I give you the graph, let's see if we can actually wrap our noodle around how they're going to present the data. So look up, please. Let me zoom in. So here's our table. First of all, if they were to ask you to plot this data on a graph, look at it, and since we're going to be doing these in electronically, either on a Chromebook or some of you are going to be on the iPads, think about it. You're not going to have a lot of space. So what is the first observation, look up, that you would make in regards to the domain? Talk it over with your neighbor. What is the first observation that you would make in regards to the domain? All right. Who saw that, number one, there are no negative numbers? Therefore, our graph, we're going to start our x values only going in that direction. Now look at the y values. What do you notice about that one? Very good. Same thing, right? All positive values. That's the first part. The second part, since we only have so much space, talk it over with your neighbor and let them know what would be the scaling that you would use in order to represent some of this data here. What would be the scaling that you would use? Let's see, Gloria, what would be a scaling that you would use? Jillian, help her out. 20s, let's see. 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, and I'm barely right here. Talk it over again with your neighbor and see what would be another. Okay, Gio. 50, let's see. 50, 100, 150, 200, 250, 300, 350, 400, 450, 500, 550, 600. Yeah, I'll go with 50. Yeah. All right, so with that same idea, tell your neighbor what scaling would you use for my y-axis? What y-axis? Okay, Adam. Okay, 15, 30, 45, 60, 75, 90, 105, 120, 135, 150. I'll stop right there. What is the highest pulse rate? Was 130. If I was to score this, I would give you credit for that because it makes sense. Who said 20s? Who said 50s? Who said 10s? Yeah? Either one of those makes sense. Now let me show you what they saw it, how they presented. Here it goes. Not me. This is actually a problem that I got straight from the Smarter Balance. Look up. Were we pretty close on the X? Yes. Yes. Yeah, they went by 50, if you notice. But look at the Y. They went by 50s also, right? The point here is that I want it so that most of us, throughout the year, we've been scaling our coordinates appropriately with the domain and the range, right? Is the y appropriately scaled for the data that they gave us here? No. Why do you think they probably gave us then these big numbers? Talk it over with your neighbor. Why do you think they included these huge numbers over here?
They want you to continue the graph. Because
They don't want you to pass.
they want you to struggle.
Yeah. So, what do you think, Hannah? What do you think? To be pretty close, right? Everybody see that? That's one thing. Another thing is that they might give you extra questions with numbers that require you to use that same graph that's going to require that extra data above. Does that make sense? So, with that said, now that we went through that, thinking it through and this problem, now it's time for us to work. I'm going to send you the screen, this screen, and I want you that on the screen, I want you to draw a best fit line. Before you send it in, I want you to show it to your neighbor. Once you both of you agree that that's pretty close, send it in. Okay, ready? I'm going to leave that data up here.
I have a question.
Yes.
Can the best fit line go right? Can it go that way?
I'm sorry? It doesn't matter, as long as it's balanced. Yeah. We go from left to right. All right. Look up, please. So, now that we know which direction, this is what I would do. So the day that you guys use either the iPad or the Chromebooks, whatever the case, you're going to have a tool that's similar to the one that I use. So this is what I recommend. Start at the top and then move. Oh, I'm sorry, it's frozen. Then move first the arrow in the direction that the entire data is going. Okay, it's going in that direction. Does that make sense? Okay. From there, once you move the arrow, now you can move the y-intercept so that it can start matching or to best fit that data. So that's pretty close. However, we have 5 above, 2 below, so that means I need to move the arrow a little bit further up. Is that pretty close? 3 above, 3 below, and it's going through a point. All right. So the next question that they're going to ask, and in order for me not to go back and forth, is, according to the graph that you just drew, write an equation for the line. So think about it. Before you do anything, think about it. To write the equation of the line, what form will you use? Talk it over with your neighbor. What form will you use to write an equation for this line? Let's see. Volunteer. Felipe. Close? Nope. You guys don't remember? Hannah? Y equals mx plus b. Write that down on your paper. That is correct. Why? Because from here we can actually get our y-intercept. So the next thing I would do is y equals blank x blank. So tell your neighbor the y-intercept. Positive 100. That is correct. It's right here. Now, we're missing the slope. Here's another thing to think about. We need the slope. Tell your neighbor the formula to find the slope of the line.
X equals right over run. Bam. AX.
That is correct. Y2 minus Y1 over X2 minus X1. Thank you, Matthew. Which means, hold on before you log off, which means what? That we need how many points? 2 points. What would be the first one that we would use from that line? The y-intercept, which is what? 0, 100. Well, here's the point. And what's the second one? The second one that we intersect, which is right here. Everybody with me? Or you can pick one that's on the line. I'm going to pick this one right here. This one is 450 and 50. And then I just substitute and find my slope for that line. For tonight's home play, that's all you're going to do. You're going to plot the data, graph a best fit line, and then write your equation for that line. Okay? Grab a play sheet on your way out. So here, put away my iPads. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.
Wow.